So write but not solve an equation involving one or more integrals whose solution gives the value of k. Okay, so now we're talking about using y values instead of x values, which means that when we set up our integral, we have to set everything up in terms of y and dy instead of x and dx. Because now instead of talking about vertical distances, which are y values that we write into x, we're talking about horizontal distances, which are x values that we write in terms of y. And you're not used to that, so that's what makes this one a little bit harder. So what we would need to do first is change both of our equations to be solved for x instead of y. And that's what's going to make this one kind of tricky. So to solve y equals the natural log of x for x, you have to remember that a natural log has a base of e, and that to change this so that it's solved for x, you have to do e to the y equals x. Right? With logarithms, a logarithm is just another way to write an exponent, so it solves for the exponent. So we're just going to undo that. Instead of natural log base e of x equals y, we do base e to the y equals x. That's just how you rewrite a logarithm. This one's a little bit easier to solve for x. We'll subtract the 5, and then we'll change all the signs. So this would be my two equations solved for x. And what this gives me is the horizontal distance. So e to the y, that's the distance from the y-axis to that curve. And 5 minus y equals x, that's the horizontal distance to that curve. Right. So now we're dealing in horizontal distances.
Which one would be y to x?
The natural log of x curve right here, it's the horizontal distance to that curve. Okay. So we want the area of this top piece to equal the area of this bottom piece. So we're going to write an equation that says that. So we're going to write an equation for the bottom and an equation for the top and set them equal to each other, right? Or an expression for the bottom, an expression for the top, and set them equal to each other. Okay, so for the bottom area is going from 0 to k, right? We're using y values now since we're going, you know, we're cutting it in half horizontally. So we're going from 0 to k. And to find the area horizontally, it's just like vertically, except instead of top minus bottom, it's the furthest minus the closest, right? So the furthest away from here would be the 5 minus y. The furthest away would be 5 minus y, and the closest would be the e to y. So for this bottom one, we would do 5 minus y minus e to the y.
How can you really do it 5 to 0?
Because now we're dividing it using y values, right? We're dividing it this way. So we're looking this way. Right? If we were to divide it on the x-axis, we would use x values. But we're dividing it using a y. We have to use y values. And then for the top part of the area, we're going from k to whatever the y value for this intersection was. So I'm going to go back to my graph and I'm going to look at what that y value was. So from k to whatever this y value was up here. And then again, that's going to be the furthest curve minus the closest curve. So I need to figure out what that is. Let's see. If I look at the graph, the y value was 1.307. Right, was the y value where they intersected? 1.307. Yeah, so if they change it to where it's divided horizontally, or if they decide to do washers that around a vertical axis, or they decide to stack the cross sections up perpendicular to the y-axis, it does make it harder because you do have to change everything to be in terms of y. So.
Did you add those two together?
Oh, you add them together. Thank you. Wouldn't have gotten the point for that probably if I had the plus. Okay, so let's see. They just kept it all well, they did a little bit differently. We could still do it the way that we, they just knew that the total area was 2.986. Oh wait, no, I'm sorry, it wasn't plus, it's supposed to be equal in the middle. Sorry, not atom, they're supposed to be equal. Yeah, I didn't think about the fact that we didn't know what the area was. On part A, it was 2.986, so they just wanted to cut it in half, so they did 0 to K. I'm sure that they would still take it. I just wasn't thinking about the fact that we did actually already know the area. So anyway, it's 1 point for the integrand, 1 point for the limits, and 1 point for the equation. And I'm pretty sure they would still take what we put. So, okay. Let's see. There was one more of these. Or do y'all feel good about this? Do you want to look at a different kind of one? Huh? You want to do one more? All right. So 2011, it was number 3. So back on the non-calculator portion. Is that somebody here for you?
Yeah. Thank you.
You're welcome.
I'm sorry.
Yes. Yeah, it is nice. Okay. Alright, so let R be the region in the first quadrant enclosed by the graph of, and it's f of x equals 8x cubed, and g of x equals sine of pi x, as shown in the figure above. We don't need to do it for part A, but we'll just go ahead and do it. Do you know which is which?
The downward bottom is
Yes. Yeah, the bottom one is 8x cubed. An x cubed graph looks like this, and all the 8 does is stretch it out. So it's still going to have that basic shape, right? So we're seeing this part of it here. Right? And then remember, sine's going to make snakes. So the pi just changes the period of the sine curve, so it's still going to start off making the first part of a snake. Right? So this bottom one is f, and the top one is b. Alright, so part A says write the equation for the tangent line, or the line tangent to the graph of f at x equals a half. So to write an equation for a tangent line, we're going to use point slope, which means we need a point and a. So we have the point. Right? They gave us a point at 1/2. It's 1/2 1. So we're going to plug in 1 for y and 1/2 for x. All we have to do is figure out the slope. Right? So the slope comes from the derivative. So if I take the derivative of f and I plug in the x coordinate of the point that I want to know the slope at, that'll give me the slope. So the derivative of f is 24x squared. So if I plug in x, which is 1/2, 1/2 squared would be 1/4, and 24 times a fourth would be 6. And that's it on part A. Nope, all I asked about was for f on one. We plugged in 1/2 to the derivative, right? So if you plug in 1/2 to 24x squared, you're going to get a fourth, right? Because 1/2 squared would be a fourth, and then 24 times a fourth would be 6. So this is 2 points. 1 point for, I guess, for finding the derivative at 1/2, 6, and then 1 point for the answer, which is y. They moved the 1 over, you don't have to. Yeah, to find slope, you use the derivative. So y minus 1 equals 6 times x minus a half. They solve for y, you don't have to. You can leave it in point slope. Okay, part B, this is the part where we're going to regret not having a calculator. Find the area of R. So remember to find the area between two curves. We're going to do top curve and bottom curve. So we're going to be integrating from 0 to 1/2, right? Because they intersect from 0 to 1/2. So 0 to 1/2, and then the top curve was G, and the bottom curve was F. All right, let's see. Now we still have to solve it, but I'm just seeing how much they give us for setting it up, if they give us anything. So 1 point for the integrand, yeah. So we would get a point for setting it up. 0 to 1/2 of G minus F. Then 2 points for finding the antiderivative, and 1 point for plugging in and getting the answer. So it's just like the other one that we did. It was non-calculator. Okay, so we have to integrate G of x, which is the sine of pi x. And we have to integrate f of x, which is 8x cubed. So that's easy. We can do that. Alright, so for sine of pi x, I'm going to use u, substitution. Alright, so I'm going to say that u is pi x, which means du is pi dx. And I don't have the pi, so I have to give myself a pi and balance it with a 1 over pi. So I'm integrating 1 over pi sine u du, right? Because I'm replacing the pi dx with du, and I'm replacing the pi x with u. So when I integrate sine, I get negative cosine, and I'm going to plug pi x back in for u. And then if I integrate 8x cubed, I get 8x to the 4th over 4, which is 2x to the 4th. This is in the antiderivative. So for the trig, you had to use u substitute, but for the 8x cubed, you did not. So now we have to plug in 1/2 and 0. Okay. So to plug in 1/2, Alright, so if I plug in 1/2, I'm going to get negative 1 over pi cosine of pi over 2. And the cosine of pi over 2 is 0. Alright? Minus 2 times 1/2 to the 4th would be 1/6. Right? So if I plug in 1/2, I get basically negative 1/8. Right? Because this is going to cancel out. Because if I plug in 1/2, that makes this pi over 2. And the cosine of pi over 2 is 0. So I get negative 1 over 8. And then if I plug in 0, I'm going to get negative 1 over pi times the cosine of 0. The cosine of 0 is 1. Right? Because it's square root of 4 over 2, which would be 2 over 2, which would be 1. Minus 0. So this is just going to be negative 1 over pi. So it's negative 1/8 minus negative 1 over pi, so it's going to be plus 1 over pi. So when I plug in 1/2, I get negative 1/8. When I plug in 0, I get negative 1 over pi, and you have to subtract those. Alright, what you get when you plug the top number in minus what you get when you plug the bottom number in, that's only worth a point, like plugging in and getting that answer. So all of that was just a point. So a point, 2 points, point. Let's make sure we did that right. That's the hard part, this one. Yeah, so 2 points for the antiderivative, which was the the negative 1 over pi cosine pi x. And it's 2x to the 4th. And then 1 point for the answer. Negative 1 over 8 plus 1 over pi. Alright, and then part C of this one. So you can see the 2 times that they put it on the non-calculator portion, the problems are very similar. Right? They have very similar types of things, and the equation's very similar. They had one equation that's pretty easy, you could just do the power rule, and then one equation involving trig and substitution. So, oh, fun. Oh, good. Okay, so never mind. I thought it was going to be another one. I just make everything in terms of y. Okay, write but do not evaluate an integral expression for the volume of the solid generated when r is rotated about the line y equals 1. Right, so we're going to rotate it this way. Right. Alright, we are going to be using washers. So pi outie squared minus inner radius squared. We're going from 0 to 1/2 again. So the outer radius from our axis of rotation to the curve on the outer edge, the furthest away from the axis of rotation. So what would that be? The outer radius from the axis that we're rotating around to the outer edge of the area. 1 minus f of x. Yeah. Remember, we're measuring down from the. Normally, what a function measures is up from the x-axis. When you want to try to measure down, you're going to have to subtract, right? Because f of x measures up from the x-axis. So we have to do 1 minus f of x, measure down from 1. Then the inner radius would be from the axis of rotation